All right, welcome back to calc or pre-calc. So we're going to be talking about double angles, half angles, and power reduction formulas, all the good things. Okay, let me just say a word about the half angles. I never really used them outside of trigonometry class. So all the stuff for Calc 1, Calc 2, Calc 3, like it just never really came up. So we're going to do the homework that has those in them. But if you're looking at like, maybe I should memorize these, like maybe you shouldn't. Okay. Every time I've ever needed them, I've had the opportunity to look them up and go get them. So I would not recommend like this is something you really need to memorize. Okay. Not like the double angle formulas. Those you need to memorize. These, they're nice to know, but not something that you're going to say, I wish I could finish this test if I only had this double angle or half angle formulas. Not going to happen. Okay, so let's go ahead and share the screen here and see if we can't get through some of this. Okay, so here we go. We have, okay, this is one of my favorite problems that I would give to Calc 2 people, because you're going to do calculus on something like this and you have to be able to simplify it. Okay, it's just the way that is. So let's see here. We have cosine squared of 2x times sine squared of 2x. All right. Now we have power reduction formulas. Okay. And we're going to say so like 2 cosine squared theta minus 1 is equal to cosine of 2 theta. You remember this from double angle formulas for cosine? I just wrote it backwards. Okay. So we're going to have 2 cosine squared theta is equal to 1 plus cosine 2 theta. We're just adding 1 to both sides. And then we're going to divide by 2. So cosine squared theta is equal to 1/2, 1 plus cosine 2 theta. Okay. Some calculus teachers will swear by memorizing this formula. I never did. Okay. I just do this every time I needed it. And then we have cosine of 2 theta is equal to 1 minus 2 sine squared theta. Okay, so what we're going to do is we're just going to add the 2 sine theta and subtract the cosine 2 theta. So our next step is going to look something like this. Cosine of 2, I want sine squared theta is equal to 1 minus cosine 2 theta. So sine squared of theta is equal to 1 minus, we'll do it there, 1/2, 1 minus cosine of 2 theta. Okay, again, other double angle formula. And again, some calculus teachers swear by this is one that you need to know forever and ever and ever. I never memorized it. Okay, I would just do this because I memorized my double angle formulas. I was like, there's some algebra, that's enough. Okay, but it's up to you to memorize these or not. Okay, I can't tell you that not knowing them has impacted my life in a significant way because I could just get them when I needed them. Okay, so I wouldn't worry about it too much. Okay, so we have cosine squared of 2 theta. So cosine squared of an angle is going to be 1/2, 1 plus cosine of twice this angle. So that's going to be 4x. Okay, times sine squared is 1/2, 1 minus cosine of twice this angle. All right, so be careful about this 1/2 times a half. It's a quarter. Okay, now we have 1 plus cosine of 4x, 1 minus cosine of 4x. Okay, and we're going to go ahead and FOIL this out. So you can see that the cosine 4x, there's a minus cosine of 4x, so this middle terms are going to disappear. So we're going to have 1/4, okay, 1 minus cosine squared 4x. Okay, now we have to go back to this. We say, wait, they said no powers of cosine. We can have 1 power of cosine. So we're going to think this is 1/4, 1 minus, okay, I hate to do it that way. And cosine squared is equal to 1/2, okay, 1 plus cosine of twice the angle. So we had 4x, now we're going to have times 2, right? We're going to have 8x. Okay. Yeah. All right, and now we've got to sort this out. So this is 1/4. We have 1 minus 1/2, right? Minus, that's this minus, times 1/2, 1/2 cosine of 8x. Okay. What's 1 minus 1/2? Right? This 1/2 minus 1/2 cosine 8x. We've got a quarter out here. So we have 1/8 minus 1/8 cosine 8x. Now, if I was going to do a calculus step next, this is how I'd want this. Your book says, no, we don't really want that. We want something slightly different. We want 1 minus cosine of 8x all over 8. Okay, that's how they're going to want that. If you type this in, I have a feeling they're going to tell you you're wrong. Okay, and true, everything that we've dealt with in this particular section here. So this is going to be 1 minus cosine of 8x all over 8. How about 8? All right, check our answer and move on with our lives. Okay, so again, careful with this. This is a classic problem I would give somebody in Calc 2. I would just, hey, you guys can do this, right? So we have something like that. Okay, use the half angle formula to find the exact value. All right. So let's go ahead and set that up. Now, I don't know the half angle formulas off the top of my head. So what I'm going to do is we're going to go ahead and write that down so we know that, a little bit. Let's put this over. Put it over there. Okay. So the first thing I'm going to do is note that the sine of alpha over 2 is equal to plus or minus the square root, big square root of 1 minus cosine alpha over 2. All right. So what we're going to do here is we're going to say, well, alpha over 2 is equal to pi over 12, right? So we're going to solve for alpha. Alpha equals 2 pi over 12. 2 over 12 is equal to pi over 6. Okay. And pi over 12 is in the first quadrant, so we know everybody's going to be positive here. Okay. So sine of alpha over 2, okay, or sine of pi over 12, okay, is equal to the positive, because we're in quadrant 1, square root 1 minus cosine of pi over 6 over 2. It is cosine of pi over 6. Okay, and this is all under a square root. Okay, so that's what we have to deal with. All right, so let's go ahead and simplify this out. Okay, so this is going to be, can I multiply this by 2 over 2? Get common denominators. So I can say this is the square root of 2 minus the square root of 3 all over 2 divided by 2 over 1. Okay, so this is going to be 2 minus root 3 over 2 times 1/2, right? Because that's how we deal with that. Square root. So this is 2 minus root 3 over 2 times 2 is 4. Okay. And we get the square root of 2 minus square root of 3 divided by the square root of 4. So this is square root of 2 minus square root of 3 squared all over 2. And that's our answer for this one. Okay. So we're going to write down 2 minus square root of 3. Okay, that's what we have. Okay, and we'll do it this way. All over 2. All right, okay. All right, moving on. All right, using the half angle formulas, find the exact value of this thing here. Okay, now let's have a look see. All I can tell you at this point is I'm not particularly happy about either anything that's going on here. Alpha over 2 is equal to 7 pi over 8. Okay, where is 7 pi over 8? Right, this would be 8 pi over 8. So 7 pi over 8 would be about here. This is in quadrant 2. So what's this? What's the SIGN? The sign of tangent in quadrant 2. Tangent of theta is going to be negative. Okay. So alpha over 2 is equal to 7 pi over 8. Okay, let's go ahead and just do that. So we have alpha is equal to 2 times 7 pi over 8. That cancels out a little bit, so that's 7, right? 7 pi over 4, it looks like. Okay. Where's 7 pi over 4? Well, again, here is here's quadrant 4, right? 8 pi over 4 would be here. So 7 pi over 4 would be quadrant 4. This would be 7 pi over 4. Okay, because we're counting up. Our reference angle is still pi over 4. But we have to remember we're in the 4th quadrant. Okay. All right. So they want to know tangent of this. So the half angle formula for tangent, did I even write that down? Yeah, I know. Right. Oh, I did. Look at that. 2 ways to get it. We could do the sine of, right, alpha over 2 divided by the cosine of alpha over 2, but since and we might do that in the next one, but the tangent of alpha over 2, this is equal to the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. I think we're okay with that. Okay, this is 4th quadrant stuff. Cosine is going to be positive. Okay, so we're going to do plus or minus the square root of 1 minus cosine of 7 pi over 4, 1 plus cosine 7 pi over 4. Okay, what is the cosine of 7 pi over 4? The cosine of 7 pi over 4 is square root of 2 over 2. And it's positive because we're in the 4th quadrant. Okay, so we have 1 minus square root of 2 over 2 divided by 1 plus square root of 2 over 2. This is all under a square root. Okay, and then where is 7 pi over 8? Again, this is a quadrant 2, right? So our tangent is going to be negative. Okay, so let's go with this. We've got 1 minus. Actually, no, let's go ahead and do this. We're going to have 2 minus root 2 all over 2. All I did was got a common denominator divided by 2 plus root 2 over 2. Again, common denominators. Square rooting the whole thing, negative. And now what we're going to do is we're just going to multiply by 2 over 2. Okay, inside of my square root. And this is going to cancel. This is going to cancel. So we end up with the square root of 2 minus root 2 over 2 plus root 2. All right. What do they want? It's the next question is like, how did they want me to write this down? Simplify your answer as much as possible. I'd like to say I've simplified it as much as possible, but we could do a couple more things, but let's see if they'll take this. Okay, so we have the square root of a fraction, okay, and what do we have? We have 2 minus root 2 over 2 plus root 2. So we have 2 minus root 2 over 2 plus root 2. Okay, now we'll check. Oh, we need a minus sign. Do we have one? We do. Oh, okay, it was okay with that. Okay, I was expecting multiplying by conjugates, having a squared up here, dealing with the square root on this. Hopefully this would have turned into a perfect square. There was a bit more we could have done. I'm glad they did make us do it. Okay, so next problem. Oops, I don't want that. I want just this. I don't want to try another. Let's just go on. Okay, what do you notice about the cosine and the cotangent? All right, so let's see here. Okay, if we know that alpha is in the first quadrant, okay, so we know that 0, alpha, pi over 2. Then 0 over 2, alpha over 2 is less than pi over 4. Okay, because all I did was multiply everybody by 1/2. So if alpha is in the first quadrant, alpha over 2 is in the first quadrant. Pi over 2, alpha to pi. This is quadrant 2. Okay, if I divide everything by 2, I get pi over 4, so it's picking up where it left off. Alpha over 2 to pi over 2. Okay, so if it's in quadrant 2, alpha over 2 is still in quadrant 1. Okay, quad 3, we have pi to alpha up to 3 pi over 2. That's 180 to 270 degrees. Okay, so it's quadrant 3. If I divide everybody by 2, we get pi over 2, alpha over 2. Okay, and we have 3 pi over 4. Quadrant 2. Okay, so we have quadrant 4. We have 3 pi over 2 to alpha to 2 pi. When I divide everybody by 2, we have 3 pi over 4 less than alpha over 2 less than pi. So again, quadrant 2. Okay. We can keep going around a circle, it's fine. All right. But there we are. So I don't know how much of this we're going to fill in. Right, quadrant for alpha over 2. For the second quadrant, we're still in quadrant 1. For the third quadrant, we've gone into quadrant 2. And for the fourth quadrant, we've gone to quadrant 2. Cosine is positive. Cosine is positive. When we've gone to alpha is in the third quadrant, we map it back to the second quadrant. So cosine is negative there, and cosine is negative there. All right. And then we have cotangent. Remember, cotangent is cosine over sine. Okay, so these are positive. These are positive. Okay, but here we're going to have cosine over sine in the second quadrant, right? Second quadrant, sine is positive, cosine is negative. So we have negative over positive. Here we're going to have negative over positive because sine is going to be that's going to be positive in the second quadrant as well. Okay. Not too concerned. All right, I think you probably have enough to go through and finish this guy here. Okay. Okay. So moving on. Okay. This one. So what we have to do here, okay, is we've got the sine of A is equal to 12 over 37. All right, so we have sine A equals 12 over 37. And we know that, excuse me, A is in the first quadrant, okay? So that means A over 2 is also going to be in the first quadrant, okay? So what we have here is we need a little triangle. Sine is 12 over 37. What the heck is this? So we have 12 squared plus b squared, okay, is equal to 37 squared. All right. Let's get rid of this and this. There we go. Do some arithmetic on the side here. So we're going to say that a squared plus 12 squared is equal to 37 squared. Okay. And then we're going to be able to say something like a squared plus 144 is equal to, I got 1369. Okay. So we got a squared is equal to 1369 minus 144, and we ended up with 5221. That doesn't look like a suspicious number, does it? But when I take its square root, we end up with 35. Okay, so this value here, this is 35. Okay. So we're going to have to do that because they're going to ask us for some double angle formulas. Look, and double angle formulas require us to know what cosine is. So that's what we had to do. Okay, remember everything is in the first quadrant here. So everything is positive. We don't have to worry about anything negatives or weird signs or anything like that. So this is sine alpha over 2. This is equal to square root of 1 minus cosine alpha all over 2. Okay, so what is this? This is going to be 1 minus, what's my cosine of alpha? So that's going to be 35 over 37, okay, divided by 2. Let's get some common denominators here. So we have 37 over 37 minus 35 over 37. There's a square root here. This is a square root, and it's over 2. It's over square root 2. Okay. So 2 minus 37 minus 35, right? This is 2 over 37 over 2 over 1. So we're going to invert and multiply. 1/2, 1/2. We end up with 1 over the square root of 37. Okay. Square root of 1 really too as well. Okay, but we have to rationalize numerators or denominators here. So we're going to do 37 root 37. So we get root 37 over 37. Okay. The SIGN sign, right? Everything is happening in the first quadrant, so we can just say first quadrant stuff. So this is going to be root 37 over fraction root 37 over 37. Okay, and that should be our sine of this angle. Okay, for the next one, we have cosine. Okay. Okay, so cosine of alpha over 2. This is equal to 1 plus cosine alpha all over 2 square rooted. So this is 37 over 37. Okay. Plus, what's the cosine of this angle up here? Right, 35 over 37. All divided by 2. Okay. So what is this going to be? 72 over 37. over 2 over 1, all square rooted. Okay, 2 times, right? Or no, not 2 times. 37 plus 35, I think is 72. Okay, so again, we're going to invert and multiply, so that's 1/2, 1/2. Okay, that cancels. 72 over 2, that's 36, isn't it? So we have the square root of 36 over 37. Here's the square root of 36 over the square root of 37. So that's going to be 6 over root 37. Okay, can't just leave 6 hanging around here. We're going to go ahead and hit this. Get the radical out of the denominator. So we have 6 root 37 over 37. And again, positive because everything is in the first quadrant. Okay. So here we have a fraction, and then we have 6 root 37 over 37. Here, 6 root 37 over 37. That looks good. And now we have to do tangent. Okay, so we're going to be clever. Okay, I'm going to say tangent of alpha over 2 is going to be sine alpha over 2 cosine alpha over 2. What the heck is the sine of alpha over 2? Well, didn't we find that over here and say it's the square root of 37 over 37? And what's the cosine? Cosine is 6 root 37 over 37. Let's see what happens. So to get the tangent, we've got root 37 over 37 divided by 6 root 37 over 37. So this is root 37 over 37 times 37 over root 37. Okay. Hey, there's some stuff that cancels. Wait, where did this go? This is here. Okay. There's some stuff that cancels. Well, this is 1/6. Okay. Again, everybody's positive. We're in the first quadrant. All right. And there we are. Okay. Let's see here. Effectively, very similar problem. Okay, except that we have to deal with the fact that we're in the third quadrant. Okay. So when we are in the third quadrant, okay, alpha over 2 is going to go from 3/4 to pi. So it's second quadrant. Okay. So we're going to say our second. Actually, I'm going to go ahead and pause. Get some breakfast here. So yeah, I'm going to go. Oh, okay, good. So let me pause. I'll come back. Okay, very good. And I took care of, made sure the cats had food and water because God forbid. Okay. All right. So use the necessary information or given information to find the exact value, simplify your answer. Very good. So in this case, right, our A is between 3 over 2 pi, A, 2 pi. Excuse me. So for A over 2, right, we're going to be 3 pi over 4 and 2 pi over 2. Okay, just dividing everybody by 2 here. Okay, so where is 3 over 4 pi? And where is pi? So what we're looking for is, here's 3 over 4 pi, right? So our pi, the alpha over 2, it's going to be between this value here and this value here. Okay, so we're looking for angles that are pretty much within here. Okay, so definitely our alpha over 2 is in quadrant 2. Okay, our original angle, 3 pi over 2 to 2 pi, we are here. Okay, so this is fourth quadrant. Okay, alpha is in quadrant 4. alpha over 2 is in quadrant 2. Okay. So we have that. All right. So we have to figure out, right? We have alpha over 2, cosine of alpha over 2, tangent of alpha over 2. Okay, so there we go. And again, okay, so cosine, no, we'll do sine first because that's part 1. We'll do sine of alpha over 2. Sine of alpha over 2 is the square root of 1 minus cosine of alpha divided by 2, plus or minus. Okay, what else do we know about this? We know that cosine of alpha is 4/5. Okay, cosine of alpha is equal to 4/5. Okay. Oh, that's a 3, 4, 5 triangle. Thank you. That's nice. Okay, but we're in quadrant 4. So our 3, 4, 5 triangle is here. Okay. So cosine of alpha 5/5, okay, in quadrant 4. Okay. So what is cosine? So the cosines stay positive because we're talking about 4th quadrant stuff. Okay. When we go to the alpha over 2, we're going to be swinging into the 2nd quadrant, so we're going to have minus signs. Well, not in sine's case. Okay, but the cosine is going to be a positive number. So we have 1 minus 4/5 divided by 2 under a square root. Okay, this is equal to sine of alpha over 2. It's quadrant 2, so we're going to be positive. Okay, so 5/5 minus 4/5, just getting a common denominator, divided by 2, okay, is equal to, okay, the square root of 1/5 divided by 2, okay. So this is going to be sine of alpha over 2 is equal to, right, 1/5 divided by 2. That's going to be 1/10. Okay, so we have plus square root of 1/10. So what we're going to do is we're going to multiply by square root of 10 over square root of 10. Square root of 10 times square root of 10 is 10. And that's going to be square root of 10 here. Okay, and we are positive. Okay, for part B, I need this. Okay, that's what I want. Okay, for part B, we have cosine of alpha over 2, but we know it's going to be in the 2nd quadrant, so it's going to be negative square root, and cosine is, what is cosine? Nope, no. There it is. 1 plus cosine alpha over 2. So this is 1 plus cosine alpha over 2. So this is 1 plus, what did we have here? We had 4/5, didn't we? Four-fifths. So 1 plus 4/5 divided by 2. Square rooted. Negative because we are in the 2nd quadrant. Okay, so this is 5/5 plus 4/5 all over 2, square rooted. So this is 9/5 divided by 2. So this is the square root of 9/10. Okay, negative. So we have cosine alpha over 2 is equal to 3/√10, negative. We have to rationalize our denominator. So we end up with negative 3√10/10. Okay, so there's our value there. Okay. All right. So, and then tangent, okay, and again, I'm going to cheat a little bit with tangent because knowing that tangent of alpha over 2 is equal to sine over alpha over 2 over cosine alpha over 2, right? So what are we going to be having here? We're going to be saying cosine of alpha over 2 is the square root of 10/10. And then we have over negative 3 root 10 over 10. Okay, so let's go ahead and multiply by the denominator, the reciprocal here, so we can get rid of, oops, I messed up. This should be, I didn't invert. Okay, this is 10 over negative 3 root 10. 10 over negative 3 root 10, okay, times, so we have root 10 over 10, and then we have negative 3 root 10 over 10. So I just rewrote this with the better thing here, I'm sorry. So this all cancels out, that's the whole point. The 10s cancel, the root 10s cancel, and we end up with negative 1 over 3. Okay, so we have negative 1/3. Okay, so let's see, fingers crossed. Oh, please fill in all the empty boxes. Oh, I didn't, okay, I should have done that. Cosine was negative 3 root 10 over 10, so this is negative 3 root 10 over 10, and sine was root 10 over 10. Okay, that should be better. Sorry, there was a problem. Okay, I when I walked off, I let it expire. I let all of them expire. Okay, so you have to take my word on this. The last one is an identity. I will do a terrible math thing and say I will leave this for the reader. Okay. Be careful. Actually, this one is a little bit easier because they guide you through it and they give you fewer options as you're going through. Okay, so they don't let you just have free reign. They kind of clamp you down a little bit to see what's going on. Okay, so yeah, I didn't write that one down. All right, good luck, and that should finish off 5.3, and I guess we're going to be doing 5.5, which is equations next time. Okay.